Alright guys, so in this video we are going to be multiplying rational expressions. So rational just meaning a fraction, and then of course multiplying means that there will be the times dot between the two fractions. So your steps you can see over here on the left, you're going to factor anything that looks like it could factor, cancel, you can only cancel tops and bottoms, and then simplify. Since we are multiplying, you're going to have a fraction times a fraction. Our property says that you can multiply straight across the top and straight across the bottom. So we'll see that actually in all the examples built in, but that's what I mean when I say simplify. Another way that you could say that is multiply. Again, your factoring methods are over here. Factor out of GCF, factor by grouping, factor by rainbow. This last one is going to be your sum and difference of cubes and difference of squares. Those are all of our special cases. All right, so let's look at example 1. So example 1 looks a little bit different than anything else in the video. These are all monomials, and I know they're monomials because I don't see any addition or subtraction signs. This is going to be different than example 2. So we'll kind of parallel these once we've finished example 1. But I don't have any addition subtraction signs, so my factoring is going to look a little bit different. I'm not going to use any of these methods as mentioned up here. I'm going to use a little bit different process. So 25, I'm just going to leave all my numbers like so, because we're going to kind of simplify those later on in the next step. X, because it's just x to the 1 power, is going to stay the same. Y to the third is going to be rewritten as y times y times y. Y squared is going to be written as y times y. And then x, this bottom x, will just stay the same because it is already to the 1 power. So there's nothing really to write out there. Now from here, I'm looking for, does anything cancel on the top and bottom? Because everything is already touching multiplication, I can go straight to cancel. So I can cancel a y with a y. I can cancel another y with another y. And then I can cancel the x's on the top and bottom. Now I want to kind of look at my numbers because you're probably more comfortable with numbers anyway. I'm not going to write them out in the prime factorization, but we do know that I could divide 25 and 5 by 5 and give me a 1 right there. And I could divide 25 by 5 and give me a 5 right there. So I'm not going to write that thing out so you can see what cancels. You're pretty comfortable with numbers. I'm going to do the same thing with the 16. I can divide 16 by 4 and have a 4, and 4 divide by 4 and have a 1. And so I don't have anything else that cancels. I like to do a little step in the middle where I write everything that's left behind just so I don't forget anything. So on this top left, I'm left with just a 5. And so I'm going to write that down. On the bottom left, I'm left with a 1 and a y. So I don't need to write the 1. I can just write this as y. On the top right, I'm left with just a 4. And so I can write that as 4. And on the bottom right, I am left with just a 1. And so I can write that kind of as a placeholder of 1. It is not 0. It is a 1 placeholder there. Now that I've got everything that's left behind, I'm going to multiply using the property that we saw in the notes, or that you saw in the learn screen of Hawks. Multiply straight across the top. Well, 5 times 4 is going to give me 20. And multiply straight across the bottom. Y times 1 is going to give me y. And so my final answer there will be 20 divided by y. Those are going to look different than anything else pretty much in the homework or in the notes, these monomials. So let's look at example 1 compared to example 2. In example 1, we said they were monomials because they had no addition or subtraction signs. In example 2, I now am seeing addition, subtraction signs in the numerators and denominators. So I cannot just start canceling. I have students who will cancel. They'll say s squared and s squared cancel. Well, that's not right because this s squared is touching subtraction. This s squared is touching subtraction. So you can't cancel those. You have to factor first. So I'm going to go through and I'm going to factor everything that there is to factor. And so on the top left, because I have something other than monomials, I have addition, subtraction signs, I'm going to use my factoring methods that were on that very first screen when the video started. Factor by grouping, factor out of GCF, factor by rainbow, and then my special cases. So I'm just going to kind of work each part of the fraction. So in this one, 4s minus s squared, well, I see that I have an s in common. And so I'm going to take that s out, which will leave me with 4 minus s. On the bottom left, there's really nothing I can do there with 2t, so I'm going to carry over the 2t. It doesn't factor. It's a monomial, so it just kind of carries over. Same thing with the 3t. It's a monomial, so there's nothing really to do factoring-wise. And then the bottom right, this 4 times s squared minus 16. Well, 4 is already factored out, so I'm actually just going to factor this part right here. Well, s squared minus 16, hopefully you catch that. That is going to be a difference of squares because I have s squared minus the difference 16, which is the same thing as 4 squared, or 4 times 4. So I can rewrite just that highlighted part, just the s squared minus 16 as s plus 4, s minus 4. And then I still have that 4 all the way out front. And so all I did was factor this part as s plus 4, s minus 4, and I kept that 4 out front. Now from here, it's just going to be a matter of canceling. I factored everything that I can factor. And so I'm now looking to cancel. The t's cancel. This one, if you watched the last video with just simplifying, we learned a trick that said if the two numbers, if the order was reversed and there was a subtraction in the middle, that I could cancel those and leave behind a -1. And so those will cancel, and they will cancel to a -1 left behind. I always write the -1 on top just so it doesn't get forgotten. So now what I am left with, I'm left with on the top left, s times -1 or negative s. On the bottom right, the bottom left, I'm left with just a 2. On the top right, I'm left with just a 3. And then on the bottom right, I'm left with 4 and s plus 4. So I've got that 4 and the s plus 4. Just something to make note of, these two s's do not cancel because that thing is touching addition or they are not common factors. So now I can use the multiplication property that says multiply straight across the top. Well, -s times 3 is going to give me -3s. Multiply straight across the bottom. 2 times 4 times s plus 4. Well, I can multiply 2 times 4 to give me 8. And then times s plus 4. You do not need to distribute that 8, just leave it like it is. That will be my final answer. My last example is going to be 81 minus x squared divided by x squared minus 18x plus 81 times 11 divided by x plus 9. And so I started to do some of this for you so that it would make the video go a little bit quicker. But I'm going to factor 81 minus x squared. Hopefully you notice this to be an example of difference of squares, because I can write 81 as 9 times 9 and x squared as x times x. And so it's a difference of squares, and so I will fill in my fraction to have 9 plus x, 9 minus x. Notice this order right here. This order has to stay the same as the problem. The 9's come first, and then the x's come second. Now the bottom left, this x squared minus 8x plus 81, you can take a second to pause the video, do rainbow, but there is the work for that, and I get x minus 9, x minus 9. These two on the right, they don't factor because 11 is just a whole number, and then x plus 9 doesn't have a GCF or anything in common. So once I've factored everything, I am left with 9 plus x, 9 minus x. That's this part right here. And then on the bottom of that, I'm left with x minus 9, x minus 9. You could write that as x minus 9 squared, but it doesn't particularly matter right now. And so here's what I'm left with. Now I'm going to look for things to cancel. And so I have this x plus 9 and this x plus 9, 9 plus x right here, 9 plus x and x plus 9. Those cancel to 1 because order doesn't matter over addition, so those are actually the same thing. Here, though, this is the little trick we just saw in the last example where I have the order reversed over subtraction. And so those are going to cancel, but they're going to cancel and leave behind a negative 1. Now, you could have canceled it with this one or with this one like I did. It doesn't really matter. You'll just cancel it with one of them. Nothing else cancels, and so I'm left with that 11 still because I didn't touch it. Over here on the top left, I just have a negative 1 left behind. On the bottom left, I'm left with 1x minus 9. Top right, we already said that one was 11. Bottom right, that is going to just be a 1 because it all canceled. There's nothing left behind. Now, my property for multiplying says multiply straight across the top. Negative 1 times 11 is going to give me negative 11. Multiply straight across the bottom. X minus 9 times 1 is going to give me x minus 9. And that would be my final answer.